Okay, in the last video we talked about how things became charged, right? So when electrons move from one place to another, something can gain a charge. Today we're going to talk about how charges affect one another and how they exert a force on one another. So remember that force causes a movement of an object towards or away from each other. So force causes a movement of an object, and in this case a charged object or a charge itself, and it can be either towards or away. So force causes movement of an object towards or away from another object, right? And in this case we're talking about charged objects or individual charges like electrons or things like that, okay? So when we're talking about the force on charged particles, we call this the electric force. Okay, so electric force, or I like to write it like this. Now, we have already experienced one other kind of force like this, because an electric force is actually a field force. Okay? A field force, if you recall, is a force that does not require any contact. So there's no contact necessary between the two objects. And you remember the other field force that we've already talked about is gravity. Okay? So gravity is another field force. You can experience gravity even if you're not, standing on the surface of the object that has a gravitational pull on you. Okay? So the equation that we have for gravity, remember, is that force due to gravity is equal to some big gravitational constant times the magnitude of the masses of the two objects divided by how far away they are apart squared. Okay? So, electrical force is very similar to this. It is a result of the magnitude of the charge. So we've got the magnitude of the charge as opposed to magnitude of the mass, so magnitude of the charge, as well as their distance away from each other. Okay? So the equation for electric force is actually called Coulombs Law. Okay? And it looks very similar to the gravity equation. So it is that force electric is equal to Coulomb's constant, which is K. Okay, sometimes it's written K little c. And then the magnitude of the two charges, Q1, Q2, all over their distances squared. So the closer they are together, the stronger the force is going to be. And then the stronger the charge is, the stronger the force is going to be. Okay? Now, Coulomb's constant is a known value. Okay, this is Coulomb's constant. Okay, and it is equal to 9 times 10 to the 9th, and it's newtons times meters squared all over a coulomb squared. So remember, it's always some crazy unit so that everything cancels out and we're left with newtons. Okay, so that is Coulomb's constant. Okay, now there's one other way that we can see this equation, and that is written like this. Hold on just one second, let me find the equation. We get force electric is equivalent to and it's 1 over 4 pi e sub naught. I know that's really crazy, but that's another way of writing Coulomb's constant times Q1 Q2 over R squared. Okay, so this is kind of weird, but you'll see it written like this. This little e sub naught is called the permittivity of free space. Not to be confused with the permeability of free space, which we'll talk about when we get to magnetism. It is permittivity of free space. Okay, and it's some weird number. It's actually it's a constant. It's 8.85 times 10 to the negative 12th, and it's coulombs squared over newtons times meters squared. Okay? And really, if you think about it, just the sound of it, it's the permittivity of free space. It's really a value that defines how easily force can be exerted through space. So again, don't let this get you, confused. It's just two different types of notations and two different values. Okay, so remember that this k is actually equivalent to this 1 over 4 pi e sub naught. So you might see it this way, or you might see it that way, but essentially it is the same equation. Now, in the next video, we'll actually be applying Coulombs Law. Okay, so remember that force is a vector, so we'll be working with single forces, or we might be working in multiple forces, and we'll go back and we'll rework on our vector math and the idea of equilibrium.